folks, let's look at number 4. It says the temperature on a particular day in degrees Fahrenheit, h hours after 6 a.m. is given by the function t equals f of h. The graph is shown below. So if this is my t function, right, this is essentially telling me, if you tell me how many hours after 6 a.m. it's been, I'll tell you how hot it is. Right? Give me a time or a number of hours after 6 a.m. and I'll give you a temperature. And this says if the graph is a polynomial, which of the following best describes the polynomial? And even though I'm not going to scooch down right now because I just don't have enough space to get it all in here, really the question is asking us to talk about the degree of the polynomial, right? And the lead coefficient. Those are the options. So we're going to take a look at what we've got and see if we can discern anything about either the degree of the polynomial or the lead coefficient. Now, since this is a polynomial, I can assume there are arrows here. All right. And one thing I will take note of is since both arrows are going in the same direction, right? They happen to both be going up. But since they're going in the same direction, that means I'm going to have an even degree, right? So I'm going to say both ends in same direction. That tells me even degree. Now they both happen to be going up in this particular problem, but if they were either both up or both down, that's going to be an even degree polynomial. If one is up and the other is down, whether it's right end up, left end down, or left end up, right end down, if they're in opposite directions, then you know you have an odd degree polynomial. So since I have an even degree polynomial, even though, again, I'm not going to scooch just to see it, I can rule out options B and C. So you can't see me doing it. Let me scooch up just a wee bit. All right. All right. You see me ruling out options B and C. I put little X's through them because it talks about having an odd degree here. And I might have a degree 2 or degree 4 because I have an even degree polynomial. And I can rule B and C out because the ends go in the same direction. Okay. Now, one thing I will say is because this right end is up, right? When the right end is up, you have a positive lead coefficient. So I'm going to say specifically because the right end is up, that means I have a positive lead coefficient. Coefficient, I can spell it, there we go. If the right end had been down, then I would have had a negative lead coefficient. So we can tell the sign, or the sign of the lead coefficient, whether it's positive or negative based on the right end. All right, and we can at least get some hints about the degree of the polynomial itself based on if both ends are moving in the same or opposite directions. So if I have a positive lead coefficient, then I'm gonna wind up with answer D. And I'm gonna scooch this up again. Let's see if we can get all of this in view. I think I can get pretty close. If I look at my answers, now I'm just competing with options A or D. This is the word negative, right? So this one is now out, and that gets me to D, right? So positive, even degree. Oh, you can't see what I'm circling. Let me scooch it up just a wee bit more. The fact that I had the word positive and then it was an even degree, that's what gets me to this answer. And the other thing that would kind of clue me into it being degree 4 is I had 3 extrema. I had a relative min, a relative max, and then a global min here. And when you have 3 extrema, it's not uncommon for you to have a degree 4 polynomial, right? So for the cumulative number of max mins you have, sometimes, not all the time, but how about a good chunk of the time, right? If I had 3 extrema, one higher than that is the degree of my polynomial. All right, thanks so much. Bye.